The vertex shader only knows about a single vertex at a time. It normally doesn't know about the whole triangle. So this statement is false. The vertex shader is given just one vertex at a time, so has only its position. The second statement is true. The vertex shader can output the shading normal, which is then interpolated across the triangle's surface. The fragment shader will probably want to normalize the shading normal before using it. The third statement is also true. Even though the vertex itself does not have a color stored in it, the vertex shader can compute and output anything it wants. Even though we call the outputs things like position, normal, color, and so on, as far as the GPU is concerned, it's all just data to interpolate. The fourth statement is false, for the same reason the first is false. Each vertex is processed separately by the vertex shader, so data from a specific vertex cannot be passed to the fragment shader in this way. You could work around this limitation by doing expensive things like storing the data for all three vertices at every vertex and have the vertex shader sort it out. A better solution is to use a geometry shader, if available. Currently, it's not supported by WebGL. How many times have I said this? But I really do expect this will change in the future. When available, the geometry shader is optional and is applied after the vertex shader. It allows you to access the data for the triangle as a whole. You can, in fact, use the geometry shader to create new points, lines, and triangles.